Hello everyone, welcome to this new video concept where I'm gonna show you how I did my internship. So my internship was mostly about multiplex immunohistochemistry, and this means that we do multiple staining rounds to show a lot of certain markers. And in this video I'm gonna show you the protocol of one staining round that I did. And the topic is about glioblastomas, which is a type of brain tumor, and here we look at the tumor microenvironment of this glioblastoma. And so what I'm doing here now is I take one of the samples and I put it on, I don't know how to call it, but it's something that holds the sample. And if you hold it, like I'm doing now, and put it in a buffer, the buffer goes like on the top of this thing, and then the buffer will like slide over the sample, and we do this for all the samples. I also have to mention that in the first couple of minutes, I'm gonna talk Dutch, because I'm from Belgium, but that was because I first filmed this out of my own curiosity, and just to look at it again afterwards. So that's why I talked in Dutch at first, but then I thought, oh, maybe I can put it on my channel, and then from a certain point I start talking English. So just a heads up. Nu moet ik gewoon even wachten tot al die buffer gezakt is. En dan moet ik daar Student Black in doen. Want dat laat ik zelf zien, I guess. Oké, dus nu ga ik er Student Black in doen. Ik moet nog een paar dingen pakken. Dit boxje. Bad, of course. En je kunt het Student Black doen, zonder Student Black. Dus. En ik zit onder de flowcast, ik weet niet eens of mijn gsm er mag staan. Maar alles voor de video, I guess. Dus nu doe ik gewoon 150 microliter Student Black in iedere sample. En 5 minuten incuberen. En dan zijn we terug. Dus na 5 minuten incubatie gaan we 3 keer de samples spoelen met 1 keer TBS. Door dat gewoon hier van bovenin te spuiten. Dat doen we 3 keer in totaal. En terwijl dit het wassen is, want dat duurt even eerder dat die TBS zeg maar naar onder gaat. Terwijl dit bezig is, gaan we normal coat serum voorbereiden. Dus nu gaan we de normal coat serum maken. Dat is bedoeld voor non-specifieke bindingen tegen te gaan. En daarvoor gebruiken we dit is normal coat serum, maar we moeten daar een verdunning van maken. En dat is 1/20. We hebben 10 samples in totaal, maar we tellen voor 11 samples, dus zodat we zeker genoeg hebben. En we verdunnen dat in TBS, dus ik ga weer even de TBS moeten pakken. Dus ik heb 1 Eppendorf met TBS in, dus dat is oké. En dan moet ik gaan berekenen wat. Dus het moet 150 microliter normal coat serum per sample zijn. Oké? Dus dat betekent als ik 11 samples stel, dat het 1650 microliter in totaal is dat ik moet maken. En dat ga ik hierin doen. In deze. En dus ik heb dit protocol vaak gedaan. En ik weet dat, dat ik dus 82,5 microliter normal code serum ga nodig hebben. En 1567,5 microliter TBS. Dus ik pak mijn pipet en ik doe eerst de 1000. Pipeteer ik gewoon over van deze TBS. 1000. En daarna zet ik dat op 567,5. 567,5 ongeveer. En dan doe ik dat er ook nog bij. En dan heb ik dat al. En dan moet ik nu nog 82,5 microliter van de normal code serum van dit hier nog bij doen. Oh, die tipbox is leeg, dus ik ga even moeten veranderen. Oké, mijn tipbox is bijgevuld, dus nu kan ik 82,5 microliter van deze normal code serum hier aan toevoegen. Dat is de normal code serum klaar voor zelfs bij de samples toe te voegen. Hè. Beetje vortexen. En nu het leukste van allemaal is gewoon de hele tijd wachten op het wassen. because sodium black is toxic, we're gonna have to like change the tissues here because it's toxic and we want to limit the chances of touching it. So we take new tissues to put underneath our samples. Like this. Put our samples back on it. Clean it a little bit here. And yeah, now we're gonna add the normal goat serum we made previously. Vortex, mix it again, and now we take again the pipette with 150 microliters, and gonna take a tip, and we're gonna start pipetting again. So open this, and yeah, 150 microliters per sample. Three, 4, 5, 7, 8, 9, 10, 11. Now, you heard me say go from 5 to 7. That's because I started with 11 samples. However, samples number 6 was left out because it wasn't good. The sample was folded, and with the imaging you couldn't really see anything, so we left it out. So now I went from sample 5 to sample 7. That's it. And I like to count out loud, so it's easier for me to know where I was, because if I fuck up just one pipetting, if I pipette the wrong sample, for example, twice or not, it's over. The sample won't be stained well, so yeah, so we have to be careful about that. So now we're gonna have to wait 5 minutes again, and now we're gonna have to wait 5 minutes, and then we can wash it again with this TBS buffer 3 times, after which we can add our primary antibodies. Okay, so I waited 5 minutes, and now we're gonna add the TBS. Yippee! It's a lot of waiting, this procedure. However, the end result is very, very nice. I will show you some examples at the end of this video, to see, so you can see what I see, and yeah, this is definitely worth the wait. So now we're gonna have to do this 2 more times after this one, and then I'll be back. However, no, I can already make the primary antibodies together with you, so let me get them. Okay, so again, we're gonna take this, we're gonna take 2 Eppendorfs, one for the solution itself, and one for the antibody diluent. So first we're gonna add that. So this is the antibody diluent. So previously with the NGS we used the normal goat serum, we used TBS as diluent, but now if you work with antibodies, we use Dackel's antibody diluent. We're gonna put that in this Eppendorf. It comes out with like droplets. And now I'm gonna look at the protocol. So in my protocol, it says the antibody has to be in a 1 in 100 dilution. So what does that mean? I'm gonna write it down. So that means we have 11 or we're gonna count for 11 samples. So that means 11 times 150 is 1650. In total, that's our total volume. However, we're gonna have a dilution of 1 in 100. So what does it mean? We divide 1650 by 100, and then we get 16.50 microliters of the antibody, plus, I'm not super good at math, so I use a calculator. I could probably do this out of my head, but we always want to be sure, right? So 1650 divided by 100 is 16.5, and we need a total volume of 1650, so we do 1650 minus what we calculated was 16.5, and that's 1633.5, and we're gonna need that much microliters of this taco diluent. So again, sometimes you look if you can add the TBS to the samples again for washing, but I can't right now. So take again this pipette, put it on 1000, and we're gonna add the taco antibody diluent. So first 1000, and now it's the 633.5 that we just calculated. 633.5. So now we have our diluent in it, and now we're gonna add our primary antibody. This one is in a very small bottle. Normally it's in like an Eppendorf as well, but this one is special. It's like more in this flask or in this bottle. And of this, we calculate we needed 16.5. So we're gonna take the 100 microliter pipette, because this one has this range. 16.5. We're gonna use the 100 microliter tip box. Oh, sometimes I take the pipette tip before opening the bottle, which is a small mistake I'm still making to this day. But then I just do it like this. So the primary antibody, by the way, that I'm using now is CD163, and CD163 is a marker for tumor-associated macrophages, or macrophages in general. So we're gonna hopefully have enough still left in this bottle. We do. We add it to our diluent, and we close it again. So now that we have our primary antibody dilution of 1 in 100, we can throw this away. and we remain with our antibody diluent dilution. We mix it. I always do this first and then I vortex. And then again you look if the TBS, you can add more TBS to the sample. So now I'm still just doing the secondary washing step. So after this one I'll have to do it one more time and wait and wait and wait. So then after my third washing step and after it has like I can show you. So I add the TBS on the top and then it will slowly go down, washing the whole sample. So you can see it there. TBS is here and it will like slowly go through it and wash away things that don't have to be there anymore. So I'm gonna do that one more time and then I'll be back with you for adding the primary antibodies, the CD163, and then we can continue. Okay, so I waited again for my washing steps and now we can add the primary antibodies. So again, this is CD163 and yeah, like I said, it's a marker for tumor-associated macrophages. We will stain these macrophages inside of glioblastoma samples and astrocytoma samples. And we will look where they are located, what their interactions are with other types of cells, and yeah, that's all inside this. Okay, so 150 microliters again. I will vortex to be sure that it's all mixed well. And yeah, then we can start. So 150, I have my primary antibodies, and I can start pipetting. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11. So now the primary antibodies are onto our samples, and now they have to incubate. You could choose, like, if you can do it, you can do it for 1 hour in 60 degrees Celsius. However, we always do it overnight in a very cold room. So now that it's added, I can put this on it. It's aluminium foil. It's not really needed. Normally you need aluminium foil like this for the secondary antibodies because they have fluorescent, they have like fluorophores on them and they will get excited by light. So aluminium like reflects the light, so the fluorophores won't be excited. The primary antibodies don't have that, so it's not really needed to have aluminium foil, but we just do it. Yeah, so now I'm gonna take this to the cold room. I forgot what temperature it is in there, but yeah, we just set it there, wait one night. So tomorrow I will be back for the second part of my staying around, and yeah, I'll see you then. Okay, welcome back everyone. So this is the next day. Yesterday we did the primary antibodies. Now they come out of the cold room and we're gonna start with the secondary antibodies. So now the antibodies that are targeted against CD163 are bound on the CD163, but now we're gonna have to add something so that we can image it, so it gives off fluorescence. So the secondary antibodies are made against the primary antibodies, so the secondary bind onto the primary, and then with the scanning, light will be laser will be pointed towards the samples, so that the fluorescent labels will give off their own light, and this can be measured with the measuring tool, like the scanning that we do. But of course we have to start with some washing steps, like always. So we have some TBS tween. So we do 2 times TBS tween and 2 times TBS, and then we add our secondary antibodies. So here we go. This is TBS tween right now, the first of the 2. And now we wait again. But while this is happening, we can already prepare our secondary antibodies. Yes, so I'll get them now. Oh yeah, like I said yesterday, if you work with antibodies, we have an antibody diluent, so I have to get that one too. So, antibody diluent and our primary or secondary antibodies. Again, we're gonna have to use 2 Eppendorfs. We'll do the antibody diluent in one of the Eppendorfs. The dilution we need is 1 in 300. So again, we have a total volume of 1650. Dividing that by 300 gives us 5.5. So if you do 1650 minus 5.5, you get what you need for, you get how much antibody diluent you need. So that's 1644.5. So 1000 and 644.5. And then the 5.5 of the secondary antibodies, we use other pipette tips. These are way smaller. First open this. 5.5. As you can see, nice blue color. Boop. Now we have our secondary antibody dilution, which will add 150 microliters to every sample, and then we wait an hour. But yeah, first we have to still do the washing steps. So yeah, can't do the second step yet, but I don't know if you can see it. The secondary antibodies are now at the bottom. You can see like it's very blue at the bottom, but I like to just boop, and one time and it's already not at the bottom anymore, but do it several times to be sure, and then you can vortex it again, and now you're sure that the secondary antibodies are like distributed among the whole dilution. Yeah, the whole diluent. So now we just have to wait. Favorably, you would keep this from light, so you can actually just, what I do sometimes is just put it here next to the samples so that it's protected from light because of the aluminium foil. So I will be back after I washed, and then I can show you where I add the secondary antibodies. So now the washing steps are done, and now we can add our secondary antibodies. So it was 150 microliters per sample. So let's do that. Take this box. One, 2, 3, 4, 5, 7, 8, 9, 10, 11. Then we can throw this away, and now it has to incubate for an hour under protection of light. So now it has to be under the aluminium foil so that light can't excite the fluorophores, so they will be protected and it will give better images later on. So I will be back in an hour. Hello everyone, after waiting for an hour, for you a couple seconds, I'm back, and we're going to do our next step, which is the next washing steps. So we'll need TBS tween again, and normal TBS. So again, 2 times tween, 2 times normal TBS. So I'll fill this up again. So and we can already prepare our next solution, which is TAPI. You might know it, it's to stain the nuclei. So we're gonna do that. So I'm gonna take 2 episodes again. We're gonna fill one with TBS. And we're gonna take the right amount of TBS. Now we're gonna need to take the right amount of DAPI. In this case it's 33 microliters. But before that you will always want to vortex it again. Then that's it. Now this is also a fluorophore, so you also would like to keep it from light. But first, mix it again. And I'll put it back under the aluminium foil to be sure. Don't think it's actually needed for this short amount of time, but you never know. But yeah, now we're just gonna wait again for the washing steps, and then we'll add the DAPI. Okay, so next up we're gonna add the DAPI. I already did it to one sample. We're gonna continue with the next ones. 2, 3, 4, 5, 7, 8, 9, 10, and 11. And now we wait 5 minutes, a couple of minutes, and then after that we wash with TBS, and after that we can mount our samples for the imaging. Okay, so now the last part is mounting the samples. So what we need is mounting medium. So it's a fluid that makes the cover slip attached to the slide. We need the cover slips themselves. So, and samples, of course, and we will use a pipette to pipette some droplets of the mounting medium onto the slides. So first I pipette some droplets onto the sample, onto the tissue, and then I'll just take a cover slip and put it on the sample. Then I take a pen to remove the air bubbles that form. And that's it. And we just do that for every sample. So we take some mounting medium, put it on the slides. Maybe I can show you from higher up. Maybe you see it better like this, so yeah, I think that's better. So take a slide, take some mounting medium, we put it on the slide, then we take a cover slip, just like this, then we just let it drop on the slide, take our pen, and we remove the air bubbles, because these can interfere with the imaging, as in, if you look at the image, you won't, at that place where the air bubble is, you won't see fluorescence, but you will see the air bubbles instead, so you lose data, basically. So, that's it, but we have 7 more samples to go. So now the cover slips are on the samples, and now we just have to let it incubate for a while so that the cover slips will attach to the slide very well. And all we have to do then is use the image analysis and look at the images. So I'll show you that in a couple of seconds. So now that it has incubated for an hour, we will clean the samples so that we can put it inside of the scanner. So we take a tissue and we start cleaning the samples. And we put it in something like this, the samples when they are clean. I don't know if you can see the sample. Yeah. So there can be like mounting medium on it, or it just has to be clean. Okay, so now I'm gonna put in the samples in the scanner. So there are 3 batches, and just put in one, close the door, and now we have to look on the screen and choose the right settings and the references. So first samples were astrocytomas. Okay, so now we set the right names. Yes. And now we start running, and we can scan the slides. And I will be back with the resulting images. Okay, so we finally come to the final images that we've all been waiting for. in my opinion, these are always really beautiful, so I'm always excited to see these. So in this example, we have a astrocytoma sample, and the blue colors show the cell nuclei, whereas the red shows the CD163, which I've stained throughout this whole video. And the CD163 stains the macrophages. And so, yeah, this is just an example image. However, you should be careful with interpreting this because, yeah, there is autofluorescence involved. And yeah, this might interpret with the results a bit, but it does show a lot of macrophages. And now I should also show a glioblastoma sample, and here we can see the same. The macrophages are present, and yeah, I did this with a lot of other antibodies as well. I looked at the astrocytoma samples and the glioblastoma samples and saw if there was a difference in the presence of these markers. And I also had the other project, which was about FGFR3 and FGFR3 DUC3 fusion proteins. And here I also used this technique to look at the presence of six markers and compared the presence of this to the presence of FGFR3. So, yeah, this was one staining round. I hope this was interesting to you. I myself really liked this protocol. I really liked my internship, and the results were always like satisfying to see. So yeah, I hope you really enjoyed this video. I hope it you learned something from it. So that's the whole point of this. And thank you for listening. And yeah, I'll see you in the next video.